So section 3.4 is going to be everybody's favorite section, where you're going to be proving identities. Now, the thing about proving identities is that it's tough. There's not exactly a real set form for all of these things. Now, in the video that I had you watch, I gave you a bunch of different suggestions. And what we're going to do here is practice a few that are geared towards what your homework's going to look like, because proving them in MyLab is going to be different than the work you're going to have to do in general in kind of like a face-to-face class. In a face-to-face class, I'll give you the identity and you're just going to work with one side. You can't mimic that completely in MyLab, so they'll do stuff like this. They'll give you this and say, all right, well, what does that simplify to? Now, for a problem like this, my suggestion would be to get common denominators. Now, when you're looking at these things, those two terms in the denominator have to be regarded as one whole term. So this is one term, this is another term. And you want to keep that in mind as you're trying to figure out what the common denominator is going to be. Well, the common denominator in this case is actually going to end up being the product of this times this. So to get a common denominator here, I'm going to multiply by this over itself. So effectively multiplying by 1. 1 plus cosine of theta over 1 plus cosine of theta. I'm going to do the same thing over here. This time I'm going to multiply by 1 minus cosine of theta over 1 minus cosine of theta. Now the good news is that that's given us common denominators. If I just multiply this here, I'm going to get 1 plus cosine of theta over 1 plus cosine of theta times 1 minus cosine of theta. Avoid the temptation to cancel these, because if you canceled them, you'd no longer have the lowest common denominator. 1 plus cosine of theta and 1 minus cosine of theta. So the nice thing is that we've got an LCD for both of these. So I can add them together over that lowest common denominator. So it's going to be 1 plus cosine of theta plus 1 minus cosine of theta over the LCD. Now, sometimes, depending on my mood, I get a little bit lazy, and instead of writing this times this, I'll just write LCD. In a face-to-face class, I'm fine with you doing that, as long as when you're all done, you remember that it's really 1 plus cosine of theta times 1 minus cosine of theta. In fact, I think we're going to kind of need that. So what else here? Can anyone see some simplification in the numerator?
Cosine theta.
Take the one itself.
Eliminate.
Yeah, all right, the cosine thetas disappear, right?
Yes.
You have a positive cosine theta and a minus cosine theta, they cancel each other out. Is there anything else that I could simplify?
The
1 plus
denominator.
Well, we are going to work with the denominator, but yeah, I think somebody mentioned the numerator. 1 plus 1 is 2.
yes.
All right, cool. So let's take a look here at 1 plus cosine of theta times 1 minus cosine of theta. And actually, that'll simplify as well. If you FOIL that out in the denominator, you'll get 1 minus cosine of theta plus cosine of theta. First, outside, inside, last. What are the last two going to give me? Anyone?
Minus cosine squared of theta.
Excellent. Minus cosine squared of theta. And again, in the denominator, you see some cancellation. So that gives me 2 over 1 minus cosine squared of theta. 1 minus cosine squared of theta should be familiar.
Sine squared of theta.
That's sine squared theta. anytime you see these squared terms, sine squared, secant squared, tangent squared, etc., you should start thinking about the Pythagorean theorem. So the Pythagorean theorem, just to remind you, cosine squared x plus sine squared x equals 1. If I move one of these to the other side, I get, for instance, sine squared x equals 1 minus cosine squared of x. Wow, and that's exactly what I have down here. So this would be 2 over sine squared of x, or excuse me, sine squared of theta. But that's really 2 times 1 over sine squared of theta. And 1 over sine squared of theta is secant squared, cosecant squared, cosecant squared of theta. And that's what you should have for your final answer on this one. So it's simplified actually pretty nice. Let's make that a little bit more legible. There we go. All right, so that's our first example. Did I go over any part of that that was a little too fast? Maybe you didn't follow along, or are we good there? We're good with that first one?
Good.
All right, awesome, thank you. Let's try another one kind of like that. And that'd be this one right here. And all they're asking you to do is to multiply cosine over cosecant of theta minus 1 by this term right here, which is really what's called the conjugate. I think you should have seen something like that in one of my videos. Let's give that a shot. Cosine of theta over cosecant of theta minus 1 times cosecant of theta plus 1 over cosecant of theta plus 1. So, okay, so let's take a look here. In the numerator, I got the sneaky suspicion. I'm just going to leave things as they are for the moment and write that as cosine of theta times cosecant of theta plus 1. In the denominator, we're going to end up foiling again. So, all right, here's kind of a shortcut for us. I'm really multiplying a minus b times a plus b. I'm multiplying conjugates. And when I multiply conjugates, I end up with a squared minus b squared. The middle terms are going to cancel each other out. We've already seen that. That means in the denominator, what am I going to get? I'm going to get cosecant squared of theta minus 1 squared. I'm not, I'll write 1 squared. I don't really have to because 1 squared is still 1. And once again, you see something in the denominator that looks like the Pythagorean theorem. Sine squared of x plus cosine squared of x equals 1. Since cosecant squared is really 1 over sine squared, let's take a quick look at what would happen if I divided everything in the Pythagorean theorem by sine squared. On the left-hand side, Tim, maybe you can help me out. How does this simplify?
One.
Tim? All right, go ahead. Yeah, please.
So that's 1 plus
1 plus cosine over sine, cotangent equals
cosine.
cosecant
Cosecant
squared. Good.
squared.
Now, when you compare that to our denominator, we've got cosecant squared minus 1. So how could I manipulate this to get that expression?
Subtract 1.
Subtract 1. And there you go. There's your cotangent squared of x equals cosecant squared of x minus 1. Beautiful. That's exactly what we wanted. So this is cosine of theta times cosecant of theta plus 1 over cotangent squared of theta. All right, now we're probably going to get down to some nitty gritty in terms of simplifying this. But are we good with that first couple steps?
Yes.
All right, thank you. In the denominator, I'm going to rewrite the denominator not as cotangent squared, but as cosine squared of theta over sine squared of theta. Like that. So I'm dividing by a fraction. What happens when you divide by a fraction?
Multiply by its reciprocal.
Yeah, multiply by its reciprocal. Thank you so much. So this is kind of like some scratch work. We're working around that. Let me bring that over to here. And I'm going to take and multiply by the reciprocal. So it's going to be sine, it's going to be, sine squared of theta over cosine squared of theta. So that's the reciprocal of the denominator times the numerator, which is your cosine of theta times cosecant of theta plus 1. I'll write it over 1 just to have kind of a fraction there. And this is going to work out nicer because now I can see some cancellation. Can you see some cancellation? Is there anything I can cancel that is looking? Yeah, let's cancel one of the cosines. So get rid of that and that. Not much else is going to cancel. So it's sine of theta squared times cosecant of theta, and I still have 1 cosine of theta in the denominator. However, let me do myself a little bit of a favor here and remind myself that cosecant is 1 over the sine of theta. So I just canceled out one of the cosines, and then I rewrote this as 1 over sine. Boy, and I got a sine here. If I distributed one of the sines from this, I could get that to cancel out. I don't know if you need to take an extra step to do this or not, but I'm going to show it with an extra step. A lot of you could probably do it without that extra step, but a lot might enjoy seeing it. What did I do in this step from here to here? What's the only thing I did?
Oh, you factored out the sine squared of theta into sine theta and sine theta.
Beautiful, thank you. So this term right here, I just wrote it as sine of theta times sine of theta. That's because I want to use one of these to clear up this. If I distribute this, the sine of theta here, I'll cancel that out. In fact, let's do this. So I'll have sine of theta, and then when I distribute just that one of them, I'll end up with 1 plus sine of theta. Over cosine of theta. Okay. Probably a couple ways you can finish this up, but are we okay to this point? Okay. I guess I'll finish it up this way. I'll write this: sine of theta divided by cosine of theta is tangent of theta. Tangent of theta times 1 plus sine of theta. And that's not a bad place to leave it. You could actually distribute this and do some other things. You know, there's a lot of different possibilities, but that's a good place to leave it. I think that's a nice, clean expression compared to the mess that we started out with. I think I mentioned in the video you watched for this that I still remember solving problem number 9 in whatever book that I was working with. These are tough. I won't kid you. They're tough. So that's why I only put like 18 or 20 of them on an exam. All right. JK, LOL.
You put how many on the exam?
18 or 20. All right. JK, LOL. All right. I don't put that many. Your exam is not going to be all identities. I get it. They're tough. And I'm reasonable about the number of problems like this that I put there. So, all right. Let's do a couple more. Finish this up. This next one's going to be easier. So it's this one down here. I'll circle in yellow. And it reminds me of some problems that I did for my algebra class this last semester. So 6 cosine squared of theta plus 5 cosine of theta plus 1 over 2 cosine squared of theta plus 3 cosine of theta plus 1. Let's get you in focus. Whoops. That looks a little bit better. Now the goal here is to simplify this, except a lot of you, I think, would probably be uncomfortable trying to factor something like this. So let's just do a little trick here for ourselves. This is a problem that looks quadratic in form. And my suggestion is that let's just replace cosine of theta with a u. And then that would make this a u squared term. And likewise in the denominator, u squared and u. And that turns this problem into something that at least looks a little bit more familiar. So it's going to look like this: 6u squared plus 5u plus 1 over 2u squared plus 3u plus 1. I don't know. Am I wrong? Does that look a little bit more familiar and comfortable?
Yes.
So? All right, good. Now both of these will factor. And let's start with the denominator term first. For the denominator, there's lots of nice ways, the AC grouping method way, and I know a lot of you guys have other ways to factor this thing. But the way I was taught, not the way I teach it, but the way I was taught was kind of a brute force approach. That is, you had to figure it out. But this one's pretty nice because it has to be a 2u and a u here. And the last terms have to multiply to positive 1, and there's not much choice there. Plus 1 and plus 1. Wow. Same thing up here. The last terms have to multiply to 1. The first terms have to multiply to a 6, but I can't use 6u and u because if you FOIL that out, you'd end up with a 7 up there. Can anyone figure out what the first two terms have to be?
2u, 3u.
2u and 3u. Wow. Something looks inviting here. What are you just dying to do at this point in the problem?
Cancel the 2u plus 1.
Yeah. So you pull out your special Zorro pen and go, ole. and cancel those out. And that's going to leave you with 3u plus 1 over u plus 1. Oh, but wait, u is taking the place of cosine. And you're done. Nice. Okay, let's do a couple more to wrap things up. So let's go down to this one, which I've circled in blue. And it says establish the identity 3 cosecant of theta divided by secant of theta plus 2 cosine of theta divided by sine of theta. And that's somehow or another supposed to equal 5 cotangent of theta. Now, some of the problems that I've assigned you here will actually give you little steps that you have to fill in step by step. I'm just going to show you this thing from the get-go. Now, based on what I suggested in the video, what side should we work with, the left-hand side or the right-hand side?
Left.
Left.
Left-hand side. It's generally better to work with the more complicated side. And one of the things I suggested was that maybe you write things in terms of sines and cosines. So this would be 3 times 1 over sine. And that'd be 1 over cosine in the denominator. And here we're already good. On the left-hand side, that's already sine and cosine, so we're good there. But this is a nice reminder, and we just used this trick just a minute ago. When you divide by a fraction, you invert and multiply. So it'll give me 3 times 1 over sine of theta times cosine of theta over 1, 2 cosine of theta over sine of theta. Is there any cancellation here? No, no
No,
cancellation.
but they become cotangent.
Yeah. So it's 3 cosine of theta over sine of theta plus 2 cosine of theta over sine of theta. And these are like terms now. You can directly add those and get 5 cosine of theta over sine of theta. And I'm not sure, I didn't quite catch whose voice that was. Was it Reagan? That mentioned,
Reagan.
thank you, that this is going to be cotangent or 5 cotangent theta. Nice. Well done. So a lot of different little tricks. And when you look at these problems, look for squared terms. If there's squared terms, try and apply the Pythagorean theorem. If there's too much going on and you don't know what to start, try writing in terms of sines and cosines. Sometimes I'll take a peek at the other side and try looking at both sides before figuring out which side I want to work with. Unfortunately, the one thing it takes to get good at these things is the one thing you don't want to do: practice. Sorry. It's how you get good at just about anything, is practice. Questions on that one? All right. Last one. We'll knock this one off quick. And it's kind of nice because it's a combination of a couple of last things we've done and a reminder of some stuff as well. So it's secant of u times cosine of u minus cosine squared of u equals sine squared of u. So it's the one down at the bottom. Let me click back over to my screen here and get it in focus. Come on, focus. Thank you. Clearly the left-hand side is the harder side. And not knowing what else to do, one thing we could do would be to write this in terms of your basic trigonometric functions, write everything in terms of cosines and sines. And there's something nice that immediately happens if you do that. You write it in terms of sines and cosines. Yeah, that's going to be a U. What's the nice thing that happens when we do that?
Cosine cancels.
Perfect. Cosine cancels. And I'm hoping that you guys recognize the rest of this from the Pythagorean theorem, right?
Yes.
Sine squared of U. And that's it. In establishing an identity, you work with one side to show that it equals the other side. You don't manipulate both sides, you manipulate one side. Awesome. Okay, any more comments or thoughts on that one? All right, let's get into some breakout room.